Welcome to rankstudent.com, the preferred site of millions of students around the world for digital education in science and technology. I'm Dr. Ahmed, and I will be your host for this brief session. The picture that you see on the first slide is from the NASA Hubble telescope. This chapter deals with kinematics, which by definition is a branch of physics where we study the motion of an object without asking what causes this motion. As we all know, for an object to move, there has to be a force acting on it or a torque acting on it. In this chapter, we'll disregard the forces, just focus on the motion. And within kinematics, the branch of study dealing with the motion in a straight line is called rectilinear motion. So we'll be dealing with rectilinear motion, which is motion in a straight line. For instance, if you look at this track, and if you would consider a train moving on this track, if the train is thought of as a point object moving in a straight line on this track, then that would be an example of rectilinear motion. To study motion, we need a point of reference, which is also called a coordinate system. The most accessible and most widely used coordinate system, at least the beginning stages of physics, is the rectangular coordinate system XYZ, shown here on the right hand side. The X and the Y define a plane. The Z is perpendicular to the XY plane. The three axes intersect at O, the origin, and all of them together, that is the origin together with the three axes, are called a frame of reference. Now the following terms appear in this chapter, and we must know them. This would be part of our vocabulary in physics. Path length is the total distance traveled by an object. By contrast, displacement is the distance traveled only in a straight line. As an example, if you decide to walk around the earth once from your home and come back to where you started from, you would have traveled thousands of kilometers. Your path length would be measured in thousands, perhaps in tens of thousands of kilometers. But your displacement would be zero because you got back to where you started from. Measured in a straight line, your displacement is zero. If you covered equal distances in equal time, one would say you were in uniform motion. Speed is a concept that we are all familiar with. It's the rate of change of path length. Velocity, on the other hand, is the rate of change of displacement in a straight line. Again, going back to the example that I gave, if you walked at say 3 kilometers per hour, that was your speed. But since you came back to ground zero, your average velocity would be 0. The average speed is the total path length divided by the total time interval, as compared to average velocity, which is the total displacement divided by the total time interval. Acceleration is the rate of change of velocity. Acceleration due to gravity is minus g. We all know that objects fall to the earth because of the attraction of the earth. That's gravity. And if a body is in motion under the Earth's gravity, it's considered in free fall. The important thing in rectilinear motion is to keep track of motion in the positive and negative directions. Now let's try to represent rectilinear motion through a graph shown on the right hand side here, x along the y-axis and time along the x-axis. The green line here represents the motion of an object in 1 dimensions. the point P moves from P1 to P2 in time T1 to T2. The speed is ds by dt, where ds is the total path length divided by the distance as measured by the projections from P2 and P1. The average speed is the total path length. In this case, again, this is the total path length divided by the total time interval. The total time interval is the projection P from P2 and P1. Velocity is a vector. It is the instantaneous slope of the xt curve, denoted here by delta x by delta t. Delta x as measured by the projections from P2 and P1 on the x-axis. Delta t measured by the projections from P2 and P1 on the x-axis. The average velocity is the total displacement along the axis, which is again the total displacement measured this way, divided by the total time interval. The instantaneous velocity is the tangent to the curve at a given point. Here in this case of P, T1, T2 is the tangent to the curve, and that is the instantaneous velocity of this body at this point P, which is at this time taken as a projection from P onto the t-axis. Similarly, we define acceleration as the rate of change of velocity. The limit of delta v or delta t as delta t goes to 0, namely the derivative dv by dt. It is a vector in the same direction, and since it is a vector, it could change either because of a change in magnitude or a change in direction. In the chart on the right hand side, we have illustrated the movement of a car starting from 0 velocity, building up speed gradually onto a uniform speed, and then gradually decelerating as the brakes are applied. If we take the slope of the vt curve, which is the acceleration, we'll see that the acceleration builds up to a certain point, drops to 0 as the car moves with uniform velocity, then decelerates with negative acceleration until it comes to a halt. Now in this diagram, you see that the acceleration changes abruptly. In physics, nothing changes abruptly. Things take time. And this is an idealized representation of what happens in nature so that we can understand it, do some mathematics, and have some fun trying to understand it. But in practice, in reality, in nature, things do not happen instantaneously. Now to kinematic equations. These are extremely important because examiners are fond of giving tests in this subject matter. These equations, which can be derived from simple mathematics and understanding of position, velocity, and acceleration, are given in here. They should be remembered, and there are three ways you can remember them. One is to write them down several times until you remember them. The second one is to memorize them. The last one, which is the one I prefer, is to solve a large number of problems in kinematics until they become second nature to you. For instance, the velocity at time t, v equals v0 plus at, is represented here. This v0 plus at, acceleration times t. The displacement at time t in here is the area under this curve, which is the sum of this rectangle plus this triangle. The rectangle is v0t and the triangle is half of at squared. The relationship between v and v0 is v squared equals v0 squared plus 2ax. Now if the position of the particle at time t equals 0 is x0, all we do is in the above equation substitute x minus x0 to x. Free fall is an important subcategory of kinematics. The position is given by its position at y. In this example, that is for free fall, time t equal to 0, the position is 0, y is 0. The initial velocity, if it's dropped from rest, is 0. The acceleration due to gravitational attraction, minus g towards the center of the Earth, that's minus 9.8 meters per second squared. These are important equations. You must remember them. They will be helpful to you. Now, another fun thing in this chapter, relative velocity, something that we know constantly when we move on a road in a car. People are overtaking us, or we are overtaking them. If there are two cars A and B, the velocity of A with respect to B is VAB equals VA minus VB. And similarly, the velocity of B with respect to A is VB minus VA. In other words, my perception is exactly the opposite of the perception of the guy in the other car. We can see that VBA is minus VAB. In the diagram on the right hand side, we see we are illustrating two objects that are moving. A is moving faster than B, even though B starts off with an advantage starting at 40 meters and A is starting at only 10 meters. Since A is moving faster than B, it overtakes B at time 3 seconds. Similarly, in this diagram on the right hand side, there are two objects A and B moving in opposite directions. They intersect or cross each other at time 1 seconds. An example is the high-speed train in Shanghai. When I was there, I noticed that they have built a train in Shanghai that moves from downtown to the airport at 350 kilometers per hour or faster. So occasionally when there is a train coming in the opposite direction, you can imagine, all of a sudden that train is gone with a relative velocity of 700 kilometers per hour or more. In fighter aircraft, it's really fun. You can imagine very few of us are pilots in practice, but modern aircraft fly upwards of 3,000 kilometers per hour. So if you have two airplanes coming at each other, the relative velocity would be 6,000 kilometers per hour plus. And that's a lot of fun, I would imagine. But I'm not a pilot, so we can solve the problems and conjure up, imagine what the pilots go through. Sometimes the examiners have fun giving you three objects to calculate the relative velocities, A, B, and C. For instance, you may have three cars moving side by side on a 6-lane highway. Or, as it's given some of the text, you can have a monkey moving on top of a train and you're standing on the ground. Your object A, the train is object B, and the monkey is object C. To calculate the relative velocity of C with respect to A, you calculate step by step the relative velocity of B with respect to A and then of C with respect to B, and you add them up. So you may have 10 horses competing with each other in a race. To calculate the relative velocity of the last horse on the right hand side with the first horse on the left hand side, you go through the same process. 1 with respect to the second, 2 with respect to the third, and on and on. It's also very important in these exercises too to keep track of the direction of velocities. So we have learned something about rectilinear motion, some definitions. We have been exposed to the kinematic equations. We know what relative velocity is. And the way to really grasp onto these ideas is to tackle actual problems from tests. Free fall, relative motion, or kinematic equations from previous NEET, JEE, JEE Advanced, or board exams. I would highly recommend that you log on to www.rankstudent.com. tackle as many problems as you can in kinematic motions until it becomes second nature, and you'll begin to enjoy the idea of motion. First step, in a straight line. Later, we'll study motions in a plane, 3 dimensions, and so on. Physics is fun. So, good luck to you, and thanks for your attention.